All right, so ladies and gentlemen, today we're going to do 7.5, which is called sum and difference formulas. Okay, so this is what we're going to do if we have like the sine or cosine of 75 degrees, and we need the exact value, right? Well, if I drew a triangle with a reference angle of 75, I would have 75 and 15, and I have no idea what is across from a 75-degree angle. I know what's across a 30 and a 60 and a 45 and a 45, but I have no idea what's across a 75 and a 15. Does that make sense? Or whatever type of angles you're going to create out there. So that's where we start using these sum and difference formulas. If you're at home or in class, you got your little formulas here. If you don't have this sheet, oh man, you better write these things down. All right, so first one, sum and difference of sine. I got the sine of alpha plus beta is just the sine of alpha times the cosine of beta, and then plus cosine of alpha sine of beta. Okay? Most of the time we use addition, the alpha plus beta one, but you could use subtraction anytime you use addition. So you could use either or, and I'll explain that. Okay? The sine of alpha minus beta is exactly the same. The only difference is if that's a minus, that's a minus. If that's a plus, that's a plus. Okay? Now, when you take a look at cosine of alpha plus beta, the first thing I notice is that the cosines are going to be grouped together and the sines are grouped together. Where in the sine one, it's mixed up. It's sine, cosine, sine. Okay, so cosines are together, sines are together. So cosine of alpha, cosine of beta, minus sine of alpha, sine of beta. Okay? The other thing I notice, if this is a plus for cosine, then it's a minus in between. And vice versa, if this is a minus, that's a plus. Okay? Last but not least is tangent of alpha plus beta. I'm just going to show you maybe one of these, okay? But I wouldn't worry too much about this. With the tangent ones, I usually focus on sines and cosines and then briefly talk about tangent. That's more of a HPC type question, talking about alpha plus beta, okay? Because the formula is the tangent of alpha plus tangent of beta over 1 minus tangent of alpha times tangent of beta. You start looking at those problems, it starts getting a little tricky with the simplifying, okay? So we'll briefly talk about that, but I would worry more about sines and cosines, okay? Okay. So let's put this into action. So as I take a look at example 1, I've got the cosine of 105, right? If I drew that reference angle, that would put me in the second quadrant, and then I'm dealing with a 75-degree angle. I have no idea what side length is across from a 75. Okay, so again, we're trying to come up with the exact values. For me to do this, I need to break this angle down into two angles I'm familiar with. All right, so let me grab my little pretty markers here. All right, so first thing I notice is the last digit is a 5. So anytime it ends with a 5, then I know I can break this thing down as the cosine of 45 plus another angle. Okay, so what other angle plus 45 gives me 105? 60, right? 60 plus 45 is 105, and now I know how to come up with sines and cosines of 45-degree angles and 60-degree angles, right? I know those. Okay, so that's the idea. So I'm going to take a look. The idea is this is alpha, this is beta. So I'm going to go up here, and I'm just going to write this formula out. It's the cosine of alpha, cosine of beta, and if that's a plus, this is a minus, and it's the sine of alpha, sine of beta. Or in our case, this is the cosine of 45. That's the sine of 45 over there. And then in different colors, I'm going to do cosine of 60 degrees and sine of 60. All right, let's do the sine and cosine of 45 degrees first. We'll do those in blue. So I'm going to go off to the side and make my little 45-degree angle. This is exactly what we learned in chapter 6.2, right? So I make my initial side, my terminal side is a 45-degree angle. I drop it like it's hot to the x-axis, and now I just got a 45, 45, 90, right? Now, again, some of you guys know what sine and cosine of 45 is, or off. You've been doing your homework. You know exactly what it is. I'm drawing this just for people that don't know what that is. Okay, some of you guys know exactly what this is, which is awesome. What's across from 45s, guys? Square root of 2's. Okay, and now I want cosine and sine. I want opposite over hypotenuse for sine, and I want adjacent over hypotenuse. So what's adjacent over hypotenuse from this angle here? What is this? A, H, and O, right? What's the adjacent over hypotenuse? What's cosine? Root 2 over 2. You guys okay with that? And then sine of 45 is, again, opposite over hypotenuse. That is also root 2 over 2. You guys have any questions on how I came up with sine and cosine of 45 degrees? You guys are good with that? People home, if you got questions, please use the chat. Take a look at the next one. Now I got cosine of 60. And I got the sine of 60. So again, I got a 60-degree angle I got to create. I draw my little 60-degree angle. Drop it like it's hot to the x-axis, which means that's 60, that's 30. And across from 30 we know is 1. Across from 60 is root 3, and the hypotenuse is 2. So again, we're going to be working from this angle right here, always the central angle, where that's opposite, that's adjacent, and that's hypotenuse. Okay? So I want cosine of 60, I want A over H of my green triangle. What do you guys got here? What's A over H? 1/2, 1 over 2. And then sine of 60 is root 3 over 2. Okay, we'll let that sink in there for a second. Do we have any questions on where I'm coming up with these ratios? Last thing is we just simplify a little bit. Okay, we multiply these two fractions and these two fractions together. When you multiply fractions, you multiply the tops. So root 2 times 1 is root 2. And then people always forget to multiply the bottoms for some reason. So 2 times 2 is 4, y'all. And then over here, I've got a negative, and then root 2 times root 3 is the square root of 6. And 2 times 2 is still 4. Final answer is putting these together, because math wants you to simplify. So we're going to put that all over 4, and it's just root 2 minus root 6. So final answer. At any point you guys want to check your work, just grab your fancy calculator and then type this thing in. Just double check that these things match up. Okay. So number 1, I would be in degrees because I have 105 degrees. So I'm going to go mode, make sure I'm in degrees, which I am. Okay. And then I'm going to type in the cosine of 105. Cosine 105, I press enter, and I get some decimal. I get negative 0.2588. Okay, well, that should represent this guy as a decimal. So I'm going to type this guy in now. So I've got the square root of 2. Get out of there. Minus, big minus sign. Square root of 6. Press enter. That's my numerator. Now if I divide by 4, I get the exact same decimal, so I know I did it right. You guys okay with that? All right, people at home, do you guys have any questions for me? People at home? No questions? All right. So final answer, root 2 minus root 6 over 4. These guys do not reduce because these two are on the inside and that guy's on the outside. They don't work together. Only numbers on the outside of roots work together. Numbers on the inside of roots work together. And then last but not least, these are different roots, root 2 and root 6, so you can't really combine those at all. You got to leave them separate. All right, so take a look at number 2. When I look at number 2, I'm like, oh man, this thing's in radians. And if you're like me, I don't really like radians, so I like to get out of those. Okay, so if it's me, I'm going to convert off to the side. I'm going to take this 5 pi over 12 and convert this thing. So I'm going to multiply by 180 over pi. You don't have to. You could try to break this thing down in terms of radians, but I don't want to do that. Pi's would cancel. Go ahead and reduce by 12, and then multiply by 6, and put it in your calculator. What do you guys get? 75 degrees. You guys okay with that? So the sine of 5 pi over 12 is the same as the sine of 75 degrees. Okay, so, well, sine of 75, the last digit is a 5, so I know I can take out a 45. So that's going to be 45 plus what other angle? 45 plus what, 30? 30 plus 45 adds up to 75. So Kenny, I know for sure what the sine and cosine of 45 is now, right? I know the sine and cosine of 30, right? This is going to be pretty easy. So let's go ahead, use our little formulas. Here's the idea. This is my alpha plus beta. So I'm going to go up here and use that formula right there. Okay, so I'm going to make a little squiggle here. I'm going to write that out. I got the sine of alpha, cosine of beta. If that's a plus, then this is a plus. And then they have the cosine of alpha, sine of beta. Okay, for us, alpha is 45, so I'm going to do those in blue again. So I've got the sine of 45 degrees. Over here is the cosine of 45. Okay, and then cosine of beta. Beta in our case is 30, so I've got the cosine of 30. And then sine of beta, that's the sine of 30. Well, I already drew the 45-degree triangle. I'm not going to do that again, right? We know what the sine and cosine of 45 is. We just did that, right? Root 2 over 2. Root 2 over 2. You guys okay with me doing that? Okay, no reason to redraw it. I don't have sine and cosine of 30 because over here was 60, so I'm going to go back and redraw this triangle. Okay, that's a 30-degree angle. That's the 90, that's the 60. So again, across from 30 is 1. Across from 60 is root 3, and the hypotenuse is 2. Okay, so what's cup? What's cosine of 30? Root 3 over 2. Is everybody okay with a over h being root 3 over 2? And then what's cosine, or what's sine? Sine is O over h, 1 over 2. Everybody okay with that? Okay. So we go through some simplifying, right? We take root 2 times root 3. That's the square root of 6. And then 2 times 2 is 4. And then we do the same thing over here. I've got root 2 times 1 is root 2. And 2 times 2 is 4. Final answer, I'd probably put those guys together. So it's the square root of 6 plus the square root of 2. Those are unlike roots, so leave them separate. And then just 4. Okay, when you're adding fractions together, you're just really adding the tops together. Don't add the bottoms. Don't do like 4 plus 4 is 8. That's not how it works. Okay, 1/4 plus 1/4 is 2/4, which reduces to 1/2. In this case, it doesn't reduce at all. So my final answer is the square root of 2, or excuse me, square root of 6 plus the square root of 2 over 4. Okay. You guys have any questions? Question I usually get is, Mr. Gotsch, when do we ever use subtraction? Okay, and really, if you use addition, you could also do this using subtraction. So if I take a look, and I'm not going to redo the whole thing, but if I have the sine of 75, I could make it so that it's the sine of some angle minus 45 degrees. Okay, well, what angle subtracted from 45 will give me 75? What is that going to be? Well, got to be more than 75. So add 45 to 75. 120. Okay. So if I use addition, I should also be able to do subtraction. And if I did that, if I did the sine of 120 minus 45, I would get the exact same answer. Okay? So it's just a different way to do it. Most of you guys are going to think in terms of addition, which is usually how I do it. I'm always a positive guy, right? You guys can't tell, but I'm always smiling. But I got this stupid mask on, so everybody thinks I'm a mean guy. But I'm not.
I know you're not.
Jimmy's like, oh, no, you're not. All right, so addition. All right, do you guys have any questions? It's not so bad, right? If you can do chapter 6:1, 6:2, you can do this. This is just pretty much the same thing, just using these special formulas. Okay? All right, so now if you can do example 1 and 2, where we expand it out, now we're going to condense it. Okay? So when I look at example, I'm going to jump to 4 here. I've got this thing. I got the cosine of 70, cosine of 20, minus the sine of 70, sine of 20. Again, we're trying to come up with an exact value, but I don't know about you. I don't know what the cosine of 70 and the cosine of 20 is, right? Well, the idea is, for example 1, we started on the left and went to the right and expanded it out. Well, now at example 4, you're starting on the right and trying to condense it to the left. Does that make sense? So when I take a look, the first thing I got to do is identify, is this sine or cosine of alpha plus or minus beta? So am I dealing with sines or cosines? And how do you know? So what one does this look like? Does that look like this one? Or does that look like this one? Sines or cosines? And how do you know? John?
Cosines, because on the sine one, it's multiplying sines and cosines together, but on the cosine one, it's multiplying cosines together and sines together.
Awesome. So as you take a look up here, when you're doing the cosines are grouped together and the sines are grouped together. And over here, they're kind of mixed matched, right? What John was saying, that sine, cosine, cosine, sine, they're being mixed up there. Okay, so I see cosine, cosine, sine, sine. I know I'm dealing with cosine. Okay, so then now my angles that I have is 70 and 20. What I have to do is identify if this is plus or minus in between. Okay, and how do you guys identify that? What do you guys think? Am I going to add 70 and 20 or going to subtract them? Adam, how do you know that? I agree. Yeah, so this tells me everything. Based on the formula, this is the minus, right? Then that means I'm adding. If you see plus in between, then it means subtraction. Okay, so awesome, awesome, awesome. So this guy right here tells me everything. It tells me that that's a plus. Okay, so go ahead and simplify that. So I get the cosine of 70 plus 20, which we know is 90. And then I get a lot of people just stop right there and put that into my math lab, and they're going to get that wrong. Okay? And why are we going to get that wrong? So a lot of people go to that 7. They say, okay, answer is cosine of 90. Why is that not right? No. Well, even if you typed in cosine of pi over 2, it's still going to be wrong. The other side?
After the minus?
No.
Does that be negative?
No. The last thing we got to do is actually find what the cosine of 90 is. Okay? So this whole thing represents this. Again, this whole thing represents that. And they want you to now simplify. Well, what is the cosine of 90? Okay? What, if I was to put this in my calculator, what would I get? Is essentially what they want you to do. Okay? So add these up, that's the cosine of 90. Well, what is the cosine of 90? Now, when we have an angle that is a multiple of 90, 90, 180, 270, 360, and so on, We are not thinking triangles. We are thinking the quadrantal circles, right? And you guys agree 90 degrees is up here? That's 90. We need to know these three numbers. What are those three numbers I use? IOU. And again, that's in terms of SOHCAHTOA. So at 90 degrees, what's cosine? 0. So final answer, the cosine of 90 or pi over 2 is 0. Final answer. Okay, a lot of people go all the way and get down to cosine of 90. You have one more step. Figure out what that thing is. Okay, it could be a ratio of sides. In this case, it's a position on the quadrantal circle. Okay, so final answer is 0. Easy peasy. Okay. Now, if I was to type this whole thing in my calc, guess what I would get? 0. All right. Any questions, y'all? Joe?
Where did type that in? Would you put in degrees or radians?
Yeah, I see degree symbols, so I'm going to make sure I'm in degrees. Yep. Yep. Good question. All right, last one on this page, and we have one more, and then we're done. As I take a look, now I see the tangent of 40 minus the tangent of 10 over 1 plus tangent of 40 tangent of 10. So I see all these tangents, right? So then I take a look. The one with the tangent is tangent of alpha plus beta or the tangent of alpha minus beta, right? So I know it's not sine and cosine. Because it's got all these tangents, I know it's tangent. And that's either going to be 40 plus 10 or 40 minus 10. We got to figure that out. Okay? So take a look. Am I adding or subtracting the 40 and the 10? What do you guys think? Subtracting? How do you know that?
Because it's subtracting in the formula and it's the same thing. Okay. I don't know how to.
Yeah, so here it's tangent of 40 minus tangent of 10, right? And on the bottom it's a plus. 1 plus the tangent of alpha beta, tangent of beta. Well, again, this whole thing represents that, right? This whole thing represents this. And the symbols tell me this symbol. If it's minus plus, then up here, minus plus, it's a minus. Okay, if it's plus minus, then that's a plus. The other thing is if you're going through these, if I did 40 plus 10, I have no idea what the tangent of 50 is, right? As an exact value, that would be a mess. I wouldn't know what that is. Okay, I don't have a reference triangle for that. This one works out perfect. This turns into the tangent of 30 degrees. Now, if you type that in, tangent of 30 is your answer, the tangent of pi over 6 is your answer, you're not right. Because now they want what is the tangent of 30, okay? So you're doing good, you're just not done all the way, okay? Now, is this a circle one or is this a triangle one?
Triangle.
This is a triangle one, right? So again, we're gonna make our little triangle. We did this one earlier, where that's 30, that's 60. That's 1, that's root 3, that's 2. And we want TOA, we want O over A in this case. Okay, working from this angle, that's O, that's A. So I got 1 over root 3. Okay? Leave it like that. You're a dirty rat. We want you to rationalize this thing. So all we got to do is multiply top and bottom by root 3. So my final answer, I'll write down here, 1 times root 3 is root 3. Root 3 times root 3 is just 3. So final answer I should get is root 3 over 3. All right. Any other questions on that one? So examples 1 and 2 is going left to right on the formulas. Examples 3 and 4 is going right to left, going backwards. Okay. Just make sure you answer the final question. What is the tangent of 30? What is the cosine of 90? Okay, find those values, whether it's SOHCAHTOA or the quadrantals from the circle. All right, you ready for the last one? One more. All right, here we go. So again, example 5. As we take a look, it says find the exact value of each of the following under the given conditions. Use Pythagorean theorem and SOHCAHTOA as we're doing it. And they just want cosine of alpha plus beta. So as I take a look, we'll do cosine of alpha in blue here, and then we'll go sine of beta and all that information in green. So split that up. First thing I like to do is write out my formula. So if you need to, look on the front side. Again, you should have this on your notes if you don't have the packet. You cannot learn this stuff through osmosis, right? So I've got cosine of alpha and then cosine of beta. And if that's a plus, then the formula says that's a minus. Sine of alpha, and then the sine of beta is how the formula goes. Okay, so that's the formula on the front. I just wrote it out for you. Okay. Well, right now, this is what I got. They told me the cosine of alpha was 1/2, so I know that is 1/2. And they also told me that the sine of beta was 1/3, so I have that one is 1/3. What they didn't tell me was the cosine of beta, and they didn't tell me the sine of alpha. So those are the two things that I got to figure out, right? Well, this is the information to help me figure this stuff out. So as I take a look, they gave me cosine, which is A and H, but they want me to come up with sine, which is O and H. Now, some of you guys might know what this is, and some of you might not. That's okay. But I'm going to use this information, and I'm going to draw my triangle in the correct quadrant. All right, so this guy tells me what quadrant am I in. This goes from -2 to 0, okay? Or -90 degrees to 0. So where is -90 to 0? So let's go off to the side. What quadrant is that? Here's 0. Which way is -90? Down. So that means that this angle, I don't know what that angle is, but it says that it's right here in this quadrant. So that's alpha right there. Don't even care what it is in terms of angles. And from that angle, this is adjacent, that's opposite, and that's my hypotenuse. So again, I got adjacent and hypotenuse. This is 1, this is 2. And then I can use Pythags, or this is a reference triangle that I'm familiar with. What's this guy right here, if that's 1 and 2? √3. But I'm going right and down, so it's a negative. So that's why this is important. This tells me what quadrant am I in. I'm in Q4 with that, between 0 and -90, and that's going to help you really identify, is it a positive or negative? And that's where I run in some of you guys, when you're making your triangles, you just make a triangle and draw that stuff in there, and you don't put it in the correct quadrant, which means you're just guessing on positives and negatives. Okay, we were trying to get this thing right here. So O over H is -√3 over 2. Now the last thing we got to do is find cosine of beta. And beta says that it's between 0 and 90 degrees. So 0 degrees, 90 degrees is up here. So there's my triangle, that's beta. Okay, so I put those numbers in. I know this is opposite, adjacent, hypotenuse, and they gave me sine, which is SO over H. So I have 1 and I have 3. Well, from there, I've got to figure out this missing side here, right? So how do I find the missing side? Because this is a Pythagorean identity, or Pythagorean, you know, that I don't know. And don't know these ratio of sides. Unless I use Pythags, right? So I've got this a squared plus b squared equals c squared. We're trying to find this guy, we'll call that a. B squared is 1, and c squared is 3. So we know 1 squared is 1, I'm going to subtract that over, so I get a squared equals 3 squared, which is 9. 9 minus 1 is 8, and we square root it. Now, I would always break that down. My math lab wants it simplified, right? So break it down, 4 and 2, 2 and 2. I got a pair of 2's. Are you guys okay with me saying this is 2 root 2? Yeah? So this guy's 2 root 2. And now I've got my adjacent. And now I've got my hypotenuse. Again, it's 3. So far, so good. Finish up. Multiply. That gives me 2 root 2. 2 times 3 is 6. Don't reduce that. Negative times a negative makes those positive. Root 3 times 1 is root 3. And then again, 2 times 3 is 6. So the reason why we don't reduce here is because we want to combine these two. They have common denominators, so just write them underneath the same 6 denominator. So final answer on that one now is 2 root 2 plus root 3 all over 6. And now I have that value, given that information. Okay, so give those a shot. You're going to need to practice that. Okay, this is not something you can just hold your phone up to and it's going to answer the question for you. Yeah, you photo math guys out there. Man, I hope you stopped using that. You're going to be in big trouble next year when real life hits you.